I started in Robot Wars or Battlebots, where TV shows where they're paying people to build robots and attack each other on screen, and that's a crazy world of some really advanced engineering, but also some really like childish physics. And that was great fun. So I did that from the age of like 10, 12.
On this episode of Tuned In, we've got Josh Velman joining us, who goes by the username Motorsport Engineering on Instagram. Now, this is an account that I've personally followed for a number of years. Josh is building a complete custom Hillclimb car, and it's not what you might be thinking for the average home-built, garage-built car. This is some next-level stuff. And Josh has essentially told us he's trying to build something at basically Le Mans prototype or F1 level. And he's doing exactly that. This thing is a work of art, and I always enjoy seeing his posts pop up. Specifically, Josh has gone next level with this build though, and has leaned heavily on the use of 3D modeling with the component design and layout. And he's then able to essentially validate everything in the virtual world before any components are made. And this thing is going to be exceptionally fast. It is going to weigh 850 kgs. It's going to be powered by an 850 horsepower Hayabusa V8, and it's going to rev to 11,000 RPM. If that's not enough, it's also going to produce somewhere in the region of about 450 kilograms of downforce. So you know it's going to be exceptional. In particular, with our conversation with Josh, we dived into a lot of different topics, from his background in mechanical design, and you'll be interested to find out that Josh doesn't actually have a formal university education, which we would usually expect goes hand in hand with the sort of work he's doing. We also talk about the design philosophy behind his build, why he chose that Hayabusa V8 twin turbo engine, and also about some of the considerations around the suspension design as well as the aerodynamics that goes into the build of this car. It really is an exceptional conversation, and there's a huge number of takeaways that I'm sure everyone's going to learn from. Before we get into that though, and just because it is somewhat relevant to today's topic, I just wanted to talk about an Instagram we recently put up, which is of a motorsport damper. Probably on face value, not the most exciting thing to be talking about. The reason I wanted to talk about this though is that dampers and damper tuning specifically are one of the most common questions we get asked about. In other words, how do we go about adjusting our bump and rebound settings? This particular motorsport damper that we're talking about here actually has 5 separate adjustments, which sounds like a lot, and it is. We're talking here specifically about low speed and high speed bump and rebound, so that's 4 settings, and then the 5th setting is a blow-off valve. And you might be wondering, why would we need a blow-off valve on a damper? And this is actually designed to allow the car to ride curbs and take those big impacts without actually upsetting the balance of the car. Now, the question, of course, is how do we go about adjusting our dampers? How do we go about adjusting these settings? And also, following on from that, is how do we decide what spring rates to choose? And we have recently released a course that covers exactly those topics. This is our suspension tuning and optimization course, which will teach you everything you need to know about the design, the development, and the tuning of your suspension system, including how to optimize your bump and rebound settings and how to choose the correct spring rates. It doesn't matter if you are designing a car from a clean sheet of paper like Josh has, or perhaps you're just modifying an existing production car. This course will be perfect for you. The course is valued at $149 US. However, as a listener to the podcast, you can use the coupon code podcast75. That's going to give you $75 off the purchase of your first HPA course. You can find a link in the description. All right, let's get into our interview now. All right, welcome to the podcast, Josh. Whereabouts are you joining us from today for a start?
I'm just outside London in the countryside, in the middle of some massive storm.
Oh, perfect. Now, just talking about your car. I've been following the build of this on your Instagram for a fair while, and it's pretty extreme. Can you give our listeners maybe a quick sort of 30,000 foot view of what this car is and what it's intended to do? And we can then dive in a bit deeper as we go through the podcast.
Yeah, absolutely. It's designed to go up the hill in Europe. There's a Hillclimb series that's basically a silhouette class. So race cars based on something that was in production at some point. So the ethos of the car really is how extreme can you build a classic car. So it's based on a 1969 Alfa Romeo GT AM. But underneath, I've bought an original badge. Everything else is brand new. But not brand new off the shelf. Everything is machined from scratch. Everything is designed ground up. Sort of the goal was, can you build a Formula One car without racing in Formula One? And that was a terrible thing to start on, because now I'm 4 years in and still a long way from having something running.
I mean, just looking at the journey, as far as I've seen, the attention to detail and the perfection in every element you're designing, I applaud the effort you're putting in. One of the questions I've got just based on this, so we've got an Alfa Romeo, which essentially the only Alfa component is the badge, which I love. And when you're building something that's a silhouette, as you've mentioned there, first of all, two questions in one here. First of all, how accurate does that silhouette have to be? Is that a rule that you have to abide by? And following on from that, how much does that actually limit what you can do in terms of, is that a real handicap? Obviously, cars of that era, the aerodynamics aren't what we see from today. Some of these are a bit brick-like, trying to push that through the air can be a bit challenging. Yeah. So can you talk to that a little bit?
It's pretty loose. The rules basically say if you've got an original windshield or a replica of the original windshield, it goes. So you'll see some crazy cars there that are supposed to be old Mercedes or old Porsches that look absolutely nothing like it because the aero is, extreme. Sure. So you've got pretty free reign. A lot of people are using modern cars, family cars, and turning them into race cars. There's a few old school BMWs and things like that, but the majority of it's modern. So it was quite cool to do something classic. But there's also a serious championship car that's based on the modern Alfa race car, the 4C, the little tiny sports car. And what they've built is a monster. If you look that up, it's Baccio Racing in Italy that have built a crazy silhouette version of this car, and it's a beast. So it felt like a bit of a tribute to build this, the same thing, but from 40 years prior.
Yeah, absolutely. All right, well, let's step back, because what I've seen, there's a huge amount of engineering knowledge and 3D modeling that's gone into this, and you don't just wake up, well, most of us don't just wake up one day and go, hey, you know what, I'm going to build a car from the ground up, particularly at this level. So can you give us a sort of a quick overview of your sort of background, how you actually got the knowledge required with 3D modeling and mechanical design?
Yeah, absolutely. I mean, this is my first foray into motorsport or cars at all. I've never built a car, never done anything in this world, which is probably why everything's so detailed, because I'm trying to focus on one piece at a time. My background is manufacturing and consumer products mostly. I started in Robot Wars or Battlebots, where TV shows where they're paying people to build robots and attack each other on screen, and that's a crazy world of some really advanced engineering, but also some really childish physics. And that was great fun. So I did that from the age of 10, 12, spent a few years just making stuff, turning up with a bunch of adults while I was a kid making stuff. I just got to a point where I couldn't afford to make that in the UK anymore. I'd go to these machine shops around, where I lived, and I'd be there with 15 quid in coins from a paper round, and they just had no idea what to do with me. And I'd turn up with these properly dimension drawings, everything ISO spec, and with a piece of billet that I bought on eBay. And they just didn't know what to do with me. There was this joke. They were like, oh, you should go to China. You can spend your pocket money in China. So I did. I mean, this was before China was very accessible. So yeah, well, I think they were totally right, but I don't think they realized it. It was before China was very accessible. So nowadays it's impossible to find a genuine Chinese factory unless you really know what you're doing. Back then,
Sure.
the only factories you could find, were either completely local and no advertising, or they were Western factories that had moved out to China and understood how we were using, Google and the internet. This is pre-Google being a big deal, really. So you Googled Chinese factory and you found some guy from the UK that had taken a factory out to China. So you could speak English, you could spend Western currency, pay for things on PayPal. So I did spend a couple of years designing stuff for the robots world, making some crazy machines, sort of pushing all of my SolidWorks skills, making stuff that you just could not make by hand anymore. I had access to like 5-axis CNCs when I was 13 years old, so made some silly stuff, and got involved in supply chain that way, sort of helping some of the people I met through the robot world, work with big supply chain, work out how to put stuff into China, how to take stuff back out of China. Spent a couple of years doing that, worked for some big companies, got fired when I was about 17, 18 because a few of them realized how old I was. And since then set up a business to kind of do that slightly more efficiently. So spent the last 10 years running a company that runs R&D through to initial supply chain and manufacturing for a lot of big businesses, helping them design everything. I mean, like deodorant cans to medical devices to washing machines, sex toys, super broad. But our guys design all the engineering, design how everything needs to work, go through all the certification, and then set up these supply chains and these factories to go and produce this stuff when it's in that really risky phase of making the first 10 to 100,000 units. So my world is definitely engineering. I am certainly not the top engineer in the company anymore. I'm put at the sidelines. So this is my attempt to still keep in touch with designing stuff and making stuff.
I think that's probably the most unique story I've heard of how someone gets to the point you've got to. But I mean, again, that is amazing. I applaud the efforts of how something like Battlebots has built that knowledge, and you've gone obviously pretty deep down the rabbit hole. Sounds like there was a lot of situations there where time and place worked out really well for you, getting into China as well, which it sounds like you're probably leveraging still to this day. So that's a crazy path to get you where you've got. In terms of a formal education, in terms of mechanical engineering, etc., have you got a university degree or anything of that nature, which would be pretty typical?
No, nothing. I have some rather mediocre high school results. I was doing it. I think I when I was that age, I was looking at universities and higher education to study engineering, and you'd go to these like trial days, and bear in mind at this point, rightly or wrongly, I'd spent 2 or 3 years working in supply chain, procurement, engineering, and you just have these mad conversations with professors about what they thought the engineering world looked like, and then this world that you'd actually seen. As a rather belligerent and obnoxious kid, I just couldn't get behind it. So no real formal engineering education. I've learned things by doing them and playing.
So it sounds like perhaps you actually had more real world experience on the supply chain aspects than the professors at the universities.
Well, I think it's one of the major issues with education, particularly in the UK, is that, particularly with stuff like engineering, where it's not all theoretical, it's very practical.
Sure.
The realities of the challenges in engineering and industry are nothing to do with engineering in most cases. Almost all technical problems are possible within reason. The majority of the issues around procurement and people and industrial structures, they're not really technical issues. And having played a little bit too far into that, it was very hard to then go back up and extrapolate back to pure mathematical physics when we talk about engineering.
Sure. I think the takeaway for our listeners here is that education is one path you can go down to get into a career like what you've done for yourself, but just you're obviously gone to prove that our higher education is not the only path that you can use to get where you've got. So I think that's important, and that real world experience as well. is so valuable. I see a lot of people coming out of university with the theoretical knowledge, which is great, but it's that balance between the theoretical understanding of what you're doing and then the practical application of that. And I see that is quite often a little bit lost on university graduates. Obviously, they need to go out and actually build up the real world experience too. Let's come back to the car. And you've sort of said so far, obviously, your Battlebot experience is mildly automotive maybe, but it doesn't sound like up to this point you've had a huge sort of passion for motorsport. You're not out there every weekend racing. So is that fair? And if so, what was the impetus behind designing this car, just deciding to jump in the deep end there?
I think I've always wanted to play with cars, and it's always been it's an impractical hobby, right? I think everyone listening is going to know that this is not the sort of thing you do in your bedroom. So that's a start. So I grew up around cars. My dad restores classic cars. He collects Elvis pre-war cars, so definitely not these kind of race cars. But yeah, I grew up around that sort of stuff. And I think the thing that really annoyed me about the idea of building a car was basically having to take something OEM. The idea of taking what I would appreciate is a huge amount of engineering to build a tub out of 1.2 mil steel and stamps and all of the detailing you get from that, and then you fill it with adhesive and everything else. That's a fantastic piece of engineering to build a car. To then take that apart and try and turn that into a race car just felt dirty. I really wanted to start clean slate, and so this project sort of started off as, I'll buy one of these and I'll play with it, and then all of a sudden that was it. I was designing from scratch because I just couldn't stand anything that was OEM. I'd rather take longer to spread the project out and get it done than try and make something OEM perfect.
I think anyone who has ever modified a road car or built a race car from something OEM, it's fair to say you're always dealing with design compromise, and almost always you're going to end up with something that is heavier than perhaps it needs to be if you were working from the ground up. Of course, working from something OE gives you a really good head start down the path though, as opposed to building and designing every single component from scratch. So you're definitely, again, right in the deep end with this project. One of my questions is, when you literally have a clean sheet of paper in front of you, you could do anything you want, any engine combination you want, any body shell. How do you make that first decision about what the direction is going to look like? How did that work for you?
When I said this, I think I first decided I was going to do this project on a flight at some point, and I was sat there, like 4 a.m. in the dark, like, I'm going to build a car. Then did about 6 hours of Googling what's actually underneath a Formula One or an LMP1 and going, right, that's cool. Yeah, I want to make that. So it started very much as like, well, can I get the whole, stressed engine, stressed gearbox? Can I make that fit into a road car? Because I'm not going to build a single seater. There's no way I can do that justice. So, can I build a road car-esque race car? Is there a series for that even to fit in? Did the rounds around various circuits and various race series to go and see what's going on, because you can put years of love and time and money into these things, but if there's not a series to race it, it feels a bit of a dead journey, particularly if it's not going to be road legal.
Definitely.
And settled on Hillclimb just because it felt ready for a bit of disruption. Like, there's a lot of really interesting tech there, but a lot of it's been around for a long time. And there aren't a huge number of cars going up the hill that are silly. The cars that are silly, they come from other places, or they're like, they're concept cars from big manufacturers, or they're, something coming to break a world record. They're not really pushing boundaries in the sort of day-to-day categories. And it just felt like a nice place to go and muck around, disrupt some things, and have some fun as well. Like, it's not a really serious race series where you need to be there every round. That's really important. I just don't have the time to be there every weekend. So, and you don't want to be one of those people that sets up a team and then does 3 races in the season and gets nowhere on the list. So, it was kind of all based on trying to push some limits and find somewhere to comfortably push some limits, but not piss people off. That's okay. Important. It's not a car to go somewhere and upset people. It's a car to kind of prove what's possible.
Yeah. All right. So obviously one of the fundamental choices you need to make when you're designing a car like this is what's going to power it. And you've gone with something pretty unique with a Hayabusa-based V8. Can you talk us through the decision process that you used to come to that conclusion?
Yeah, absolutely. So once I'd sort of said, right, this is going to be a Hillclimb car, it became very quickly about weight. So I spent a long time looking at various engines. Obviously, the easy option is to go for something on a crate, LS7 or something, and they just weigh way too much for the power output. That huge amount of modification required to make them light enough to be useful in this category. So started looking at some more efficient stuff. I was looking at old Judd engines. I was looking at AER, who make a lot of the endurance engines. Had a look at a few of the old LMP1, LMP2 engines that you might be able to get from breakup cars. And then just came across John Hartley's V8 Hayabusa. And it's just madness. I mean, the amount of power you get out of something so small, I probably couldn't pick it up now. It's fully put together. But when it was, an engine without any primaries on it, you could pick that up and walk around the garage with it. It's tiny, and it's going to output probably about 850 horsepower.
That is insane.
It's just silly, and you have to have such appreciation for John's engineering as well. I mean, you look at how well this thing is designed. I don't know how many iterations down the road it is now. I think my engine's 171 unit number, so I would presume that means there's 171 that exist.
Okay, right.
And even now, I mean, John calls me now and he's like, I've changed something. I'm going to send you the parts. You need to change this, and this. I've learned something. Right. And that was just really cool. And just to work with somebody who's that experienced and that technically competent, but also to work on something that's still changing was pretty cool.
So just for those who don't know, obviously with the podcast we don't get the benefit of pictures, but that Hartley V8 uses the stock Hayabusa motorcycle cylinder heads and barrels, and then a billet block basically to link the two barrels and heads together with a custom crankshaft. Is that kind of the overall view of it?
Yeah, pretty much. Yeah, and then it gets all the nice things inside, the Inconel valves and everything else to make it just about sustain the amount of power it's going to put out. But realistically, it's not too complicated, but it's all the details that make that work.
So in terms of capacity, what are we looking at, and what sort of RPM range will it run to?
What is it? So it's 2.89 litres. It red lines at 11, peak output's about 10 and a half. And we'll tune this to about 850 horsepower with twin turbos. Okay. So it's going to be hot. I mean, that package is tiny. We're talking, it's 500 mil long, the whole engine with everything in. So it's a lot of heat, a lot of power in a very, very small space.
Absolutely. And did you have sort of a number on the overall weight of that package, maybe engine with the turbochargers?
Yeah, so with turbos, I reckon it's about 125, maybe just over kilograms. But I mean, you compare that just to an LS block. An LS block must be 60, 70 kilos without anything on it.
Sure, yeah. Yeah, I don't have an overall weight for a dressed LS, but significantly more than that is a fairly safe bet. But I think the other thing that's easy to overlook is not just the overall weight. As you've mentioned, that 500 millimeters long, this is a tiny engine, and the other aspect that's even easier to overlook is I can only assume that the center of gravity for the weight on that engine is very, very low compared to something like a conventional LS.
Yeah, super low. It's a 90-degree V, and center of gravity on that engine is probably about 130 mil from the base. Yeah, so it's floor scraping, and then you mount that. Well, it's 50 mil ground clearance. You've got 20 mil of floor, and it's on that. So you're 200 mil from the ground is center of gravity on the engine. So the whole car center of gravity is basically around my waist when I sit in the car. Yeah, if not lower.
Now, when you're looking at your design options, so you've got the engine that you want to use. you've decided to go twin turbo here. Did you weigh up whether you stay naturally aspirated for the complexity advantage in terms of not needing turbochargers, not needing cooling systems for the turbos, etc.? Did you weigh that up, or is it just you could not get the sort of power level that you needed without turbos?
No, I mean, the power out of this, you can get naturally aspirated 500, 550 without too much fettling. But it was always about what's silly, what can we do that's silly? And there's a few teams out in the US that are running these in endurance classes, and they're pulling 800, 850 for 24 hours on these engines with similar turbo setups. So it felt proven enough to be stable. As a couple of people I've seen put them up to like 1,000 horsepower, which I think is basically building a bomb. That's not really a car at that point, but 800, 850 seemed sensible, and you know, adding the turbos and everything else just felt like a nice. I like the complexity of it. I wanted something super dense that when you take the clamshell off, you're like, how does that fit in there?
Yeah. Well, and looking at the renders you've got, as well as the photos of the car as it is at the moment, you've got exactly that. There's, I sit and look at a photo for 5 minutes trying to figure out how you got to a point of getting everything to fit so neatly together, which of course is the benefit of doing everything with 3D modeling before you get started. So it's
also the curse. I mean, the number of things I've machined and then got back and realized I can't fit a spanner in. I've started actually CADing in my tools, so I've got a library of tools. So because I've wasted so much time building stuff that you can't actually get a spanner into. I've got a library of tools that I'll do like an animated assembly before I produce something, because I just keep getting it wrong. But you can't see now, can we? There's no video, but if you have a look at the way the electric power steering motor's mounted at the front of that chassis, that is stupid. It's like off in 3 different axes at like 12 and 11 and 10 degrees. I don't know how I ended up there, and it looks like it was always meant to be there, but it's things like that where you're packaging stuff in such a tight space. That's what, to me, that's what's interesting engineering.
Sure. Yeah, I think that's a really, really good point you raised there about being able to build something in the 3D world. You've got complete flexibility, but then when you bring it into the real world and realize that you can't actually assemble it because you can't get a spanner in there, those are the little tricks that you learn along the way. And I can only imagine you probably learn some of those a relatively expensive way if you've already got a machine component turn up and you realize you can't actually fit it.
There's definitely a box for anybody that wants some memorabilia of parts that look cool but don't fit anywhere.
Some expensive but useless parts.
Yeah, mantelpiece pieces.
Coming back to the engine combination there, in terms of turbocharging a mid-engined vehicle, intercooling can be problematic. So how have you dealt with that?
So until about 2 weeks ago, I was going to charge cool it. And the issue I was having with the charge cooling was, A, doesn't make life much easier because you still need to put a radiator somewhere. And B, they're heavy and they're high up. I'm really struggling to keep the charge coolers that are obviously, once they're filled with water, they're like 10 kilos. I was struggling to keep them below the valve covers really in any sensible package. So I've bailed. I've gone back to intercoolers.
Okay.
I'm going to try something a bit silly. Obviously, there's no headlights because it's a Hillclimb car. It doesn't require headlights. And the GTA's got these lovely big round openings at the front for the headlights. So I've designed in ducting that takes ram air through the headlights, through the doors, because there's quite a big cavity inside the door, and then runs it through the shoulders at the back into the intercoolers, and then it's pulled out the back by the updraft from the diffuser. We'll see if it works. It's certainly lighter and it keeps the centre of gravity lower, and I'm sure there's a way that I can accelerate that air. Then probably need some sort of ducted fan or something if I can't get enough airflow. But that felt like the best compromise, because otherwise you're pulling the centre of gravity up by, this sounds ridiculous, but those charge coolers pull the centre of gravity up by like 5 mil. But you do that 10 times and suddenly the centre of gravity's up at like your head and the car wobbles around again. And the most important thing about this car is that you sit on the floor it's 850 horsepower, and when you go around a corner, it doesn't roll. That's the goal.
Yeah, yeah. And the finished weight that you're aiming for, we've talked about the target to keep weight low, but I don't think we've actually mentioned your target finished weight yet. So what are you looking at?
So it should be 850 kilos. So it'll be 1-to-1, and that's wet with driver.
Okay.
Depending on what we have for lunch.
Suffice to say, it's probably going to go okay.
I think the biggest issue is going to be trying to get that power down.
Yeah, I can only imagine, which we will get to. Part of that, of course, comes to the suspension design. And again, you've got a completely blank sheet here in terms of what you're going to be using and how that's going to be located. Can you talk to us about, first of all, how you learned what you needed to know about the suspension design and kinematics, and then how you've gone about actually developing and modelling that out?
Yeah, I think with all of this, I've taken two separate approaches depending on what day of the week it is. One day it's read everything you can, read all the maths, read all the theory, play with all the calculators, building spreadsheets and simulation models. And the next day it's just look at a shit ton of pictures and copy it. And I kind of match the two together. So it's very much based on probably LMP suspension is probably the best representation, because it's stressed engine, stressed gearbox. At the back, which is very Formula One, LMP1, but then up front you've got much shorter arms. You need quite a bit. You need some legs. You need to put your legs somewhere. So that front box is a lot wider than you get in a lot of those cars. So that's maybe more representative of something like the Glickenhaus 4S. Yes. So a lot of stealing ideas, inspiration from other cars, and then I've been working on suspension for 9 months. It's one of those things that you're either really in the mood for or you just cannot face. And so I've spent a long time going through various maths models, just trying to find. I think suspension design is something where you've got like 20 different variables, and you can maximize each one of them. You can maximize maybe two of them, but every one is detrimental to the other, and trying to find the balance that's most sensible to the car, but also adaptable, which was what I found hardest, because picking a point was easy. You're like, right, that's the perfect setup if I go to this track on this day in this weather. But then having the ability to adapt it and get the next point on the curve, often the bridge between the two of them was miles off. So there's a lot of compromise, which is always painful.
I think from my own very limited experience with suspension tuning and design, it is exactly what you said there. It's compromise. And I think you could do the best possible job of designing it and modeling everything and get yourself a starting point. But I think it's also then important still to have the flexibility to make geometry changes, roll center height changes, etc. once you've actually got the car out and tested to see, well, does this stack up in the real world? Does it actually handle like I expected, or do we need to make some changes? So you've got that flexibility built into the chassis as well to make those sorts of changes?
Yeah, I think I'm pretty sure that maths and reality will be very different. And somebody who knows how to drive the car versus me will have very different feel in that car and push things in very different places. So trying to give enough flexibility that I can have somebody who's a professional drive that car and perform in it, and I can rag it around a track and have fun and be glad I built it, are two very different setups. And I've tried to build enough flexibility to get both. We'll see. Okay. I think I'll probably still end up redesigning the uprights and wishbones at some point. But I want to get it down. I want to get it running before I spend another 9 months mucking around, because at this point, you go around in circles.
Yeah, I think that's something a lot of car builders fall into the trap of, is sort of iterative changes to something that's already been designed and built. And if you're not careful, you do get stuck in that rut of actually just never finishing the car. And then the danger that sort of comes from that as well is losing interest in the project. So I think there's definitely value in actually getting the car out in the real world and shaking it down, and then finding the inevitable things that you want to tweak and change, and you've got at least a baseline to start making those changes from.
Yeah, and getting people with some experience to actually drive the car. You can talk to a million engineers about how to design it, but until you've got a few people who know what a full range of cars feel like to drive it and go, yeah, that handles like a pig, or actually that's lovely and I really like that. That's a very hard thing to do in CAD, and nothing ever quite behaves because there's always a load more physics that you can't simulate.
Yeah, sure. Now, in terms of sort of validating the design of the components that you build, what are you doing there in terms of just basically what I'm meaning, understanding the loads that are going to be involved, they're going to be applied to, and knowing that the component you're building is strong enough and safe enough for the application?
Again, it's a mix of heart and brain. I tend to look at a part and go, right, that looks right. And that's my basis point to start FEA. A lot of the time, my looks right is a good 100% over-engineered, but that's probably quite a good place to call it quits. Occasionally, there's some parts that I feel aren't so critical that I can risk that. I'm certainly not experienced enough to be trying to find the 10%. If I can get it in a 50 to 100% safety margin, I'll go for it. I won't try and push any further because I think you can get pretty dangerous pretty quickly, especially the sort of powers, weights, speeds we're talking about here.
Definitely.
But there's quite a lot of parts where actually it's not safety critical, and you can go to town and you can do some crazy, metal laser sintering and stuff like this, and you really can turn something that was 200 grams down to 25, and that's pretty cool. Like that's the sort of silly, pointless engineering that I really enjoy, is looking at a junction box with 10 connectors on it and going, right, well, that could just be a big, heat molded T-joint, but actually that's going to be some crazy 3D printed part, and whilst it is a junction box, let's also pass some hydraulic lines through it and make it into a manifold at the same time. And yeah, that's the kind of silly stuff I like, the stuff that looks like it should be in a movie.
Sure. In terms of the mission critical components that you're saying there, you're not looking for a 10% safety margin, and you're not competing in F1, so there's no real need. That makes sense to me to have that bigger safety margin. You use the term FEA, so can you explain for those who aren't familiar with that term what that is and how you're actually using that?
Yeah, so the FEA is finite element analysis. It's basically simulating parts under load. So quite often I'll design a part, I'll key in where that part might be fixed. So if we look at like an upright's a real pig to simulate, but you've got multiple fixed points. All of those are actually dynamic points, so you can set whether a point is it's fixed in space, or that point moves and in which direction it moves. And then you can put push and pull loads against it. Is probably the simplest way to consider it. And the computer will consider what material the part is made from, what the other materials around it are made from, where the force is coming. It'll calculate all of the loading on the material itself and the properties of that material, and sort of show you, under that load, how does the part deform, or how does the part break. It will then show you the extremes as well. So if you put the force you want to put on it, this is totally fine. If you triple that, you'll see, a millimeter of bend. And if you times it by 20, it'll break at this point in this area. And it's that analysis that comes to you in all these crazy colors and shapes and patterns that you can then use to reinforce parts, but also see where you can take material out of parts, because quite often you won't realize where the stress in a material actually goes, and you can take chunks out. So that's really the best way to validate before you make something that it's strong enough. But then also a great way to show that something is too strong, and therefore you can take material out and reduce the weight of it, or play with materials as well. I often use it to go, right. Yeah, exactly. I often use it to go, okay, well, is that going to be, I don't know, 8.2 or 6.5 or 7.2 aluminium, or is it going to need to be in steel or titanium? And it's quite a good way to work out where your actual benefits are, because I think people's instincts are to go for really shiny, expensive materials because that sounds cool. Most of this car is not expensive materials because it's just not necessary, and the weight saving you get from it is minimal at best.
Okay.
And it's that sort of simulation that gives you that insight.
I can only assume here with FEA it's going to be a bit of a case of garbage in, garbage out though. So you will still need to have a realistic idea of what loads are going to be the component's going to experience. And there's steady state conditions where maybe the car's loaded up hard in a corner, and I'm guessing you could probably make some fairly realistic guesses on what kind of lateral G-force and longitudinal G-forces the car's going to experience. Then there's other aspects though that I can only assume might be a touch harder to estimate, like running a curb or something like that. So can you give us maybe a little bit of insight into how you're kind of estimating the loads that are going to be involved for your FEA?
Yeah, as you say, there's scenarios where you can do some relatively basic trigonometry and say, right, that's a triangle, forces going that way, the loading's going this way, therefore that's the kind of forces, and that's relatively simple. Then, as you say, you've got scenarios where, so you have, I guess the easiest way to talk about it is sort of dynamic loading. So you can have, let's say you hold your hand up and you push it with your other hand, and if you apply 10 kilograms of force or 100 newtons of force, and your hand moves back after a certain point, right? But then you've also got the scenario where your hand is effectively vibrating because it's moving and it's a dynamic load, and you set a vibration point, and that will, in most cases, cause you to fail earlier because you're effectively moving all the molecules of the material, and it will fail under a lower pressure. Now, the challenge with running a curve and things like that is, yes, you can make some dynamic assumptions for a wheel running. You've got the reverb from the tire and the suspension and everything else, and you can run that at, I don't know, 10 kilohertz or something. But then you've got that massive shock as well, and you've got to run effectively a curve for the dynamic loading, if that makes sense. So whilst it may be flat at your constant, then as you hit the curve, you've got a sharp incline, and then you've got the reverb coming off it. Building that line is a horrible piece of maths, and I'm not intelligent enough to do it right. So it's very much about a bit of guesswork, understanding that you don't understand, which is the most important part of simulation, because there are very few people that really understand. And then you put your safety margins in because of that. So I will design a part my target's always 50% safety ratio on the sim I'm doing, but then my sim setup will quite often have 50 to 100% of safety on it, on each dynamic, because you don't know. And you're better off making something 10% heavier and not dying than you are trying to save some weight and make something look cool. But having to tell that story in your obituary.
Yeah, I think that's probably a pretty good design philosophy for just about any component out there. So yeah, I can get behind that 100%. This sort of leads on to another aspect, and I'll be the first to admit here I am out of my depth, but I am interested by it. So this is generative design, and we've posted a couple of photos of components that we've seen over at the likes of PRI or SEMA, pistons, for example, that have been developed using additive manufacturing and generative design. Where my rough understanding, generative design, basically you can have a base component and sort of give some design elements about maybe weight or what forces it needs to be able to support, and then the computer using AI can essentially go through iterations of changes to optimize for your parameters. Have I got that about right, and how useful is that, I guess, is my question.
Yeah, that's right. You could basically, it creates these really organic shapes. Now, I'll be really frank, and I'll get some hate for this. I don't know whether people invented generative design to try and sell 3D printers. Because effectively it makes stuff that's not conventionally manufacturable, but doesn't actually give you that much advantage. There are some very specific scenarios where it makes loads of sense. Sure. They don't tend to be the common person's problems. I've certainly never seen them. But you can make some cool stuff with it. And I've played with it a bit, where you're sort of, things like an upright, where you've got forces in so many different directions, you either make a big block and call it safe, or you let the computer work it out. But again, you come back to your problem that you said earlier, is, are your inputs right? And I think that's my biggest issue with dynamic modeling is you don't know. You don't know whether what you've put in is right. So therefore, the crazy thing that comes out could still be entirely pointless. And And maybe if you've got some massive weight and cost to save, in aerospace, it makes sense. I'm struggling to see it really make sense in motorsport, but then again, I'm not Formula One. Those guys have got much more advantage from 0.1%.
Totally. So from the professional and sort of semi-professional market at the moment, are we looking at something that's maybe a bit of hype more than real, true usefulness?
Yeah, I think it's the design and engineering industry getting excited and trying to find applications, and motorsport's quite a sexy place to put it.
Definitely.
But really, the best generative design models that I've seen are still manufacturable traditionally. Albeit on a 5-axis. Generative design to me is a bit left field. I've played with it. I'm not sure it's the future, but it makes some cool stuff for an exhibition stand.
Yeah, I guess we'll see how it gets adopted as time goes by, and particularly as additive manufacturing becomes cheaper and more accessible. We'll come back to some other elements of the car as well, and you sort of talked about sort of getting the power to the ground, and there's a few elements there. We've talked about the suspension. Another one is the aerodynamics, and I can only imagine that that's played a pretty important role in your design. So you're also starting again with that silhouette Alfa body, which I can imagine being somewhat boxy and maybe not so aerodynamic. So can you talk to us about the challenges there and sort of what you've designed and what you're expecting in terms of downforce?
Yeah, so this part's very much witchcraft to me. I've had a lot of people help me on this. As a starting point, it's a terrible car. I think if you put an original 69 GTA in a wind tunnel at 200 miles an hour, it will take off. I doubt you even get any weight left on the ground. It basically wants to pull all the air underneath it, and it's kind of the least slippery thing ever, aerodynamically.
Perfect.
It's a bit of a crap starting point. The easiest place to start was to bring it down to the ground, flatten off the base. Obviously, it's got a big flat floor underneath it, 2 big channels. The nice thing about the engine and gearbox package with the sprung gearbox is you've actually got a huge cavity underneath, so you've got 2 massive tunnels, which bring you a lot of suction onto the ground, and that's the majority of the downforce. It's obviously got a rear wing and a splitter to try and use that front air sort of dam across the front bumper. The rest of it is damage limitation, really. You've got some big arches because you need a bit of width on that car. It is tiny. I think it's very hard to appreciate how small this car is. I think loaded height and weight, this car will be about 950 mil tall, maybe a meter if you're lucky.
Wow.
It is a tiny car. It's really hard to get that much power into a car that small and get that power to the ground. So a lot of the aero has basically been about just trying to compromise on what an awkward shape it is, but taking advantage of the fact that actually the frontal area is quite low because the thing is so small. Sure. There's a lot of ducting that goes through the car that's kind of cool. So I was talking earlier about the ducting into the intercoolers. Because you've got a lot of frontal kind of area, you can't do anything about the windscreen. That's by the rules fixed. But what you can do is you can take all of that grille off the front, all the headlight area and everything around there, and actually duct it through the car. So the front rads, they are from the bottom of the, just above the splitter. So you've got kind of a ram, the splitter, then you've got a ram for about 50 mil, and then you've got an inlet to the radiator for the engine. That's then ducted straight back up and over the car, so you've got sort of fast and slow air meeting to accelerate over the top of the car. Then the next grille that you've got up, that ducts through the car as well, so that then goes through these passages in the door. So a lot of that frontal air actually goes in and around the car. It's a bit experimental. We'll see how it goes. It looks quite a lot without the fancy design work like the concept from that new Lotus electric supercar. That basically isn't a car. It's more air than car in that thing. Everything's ducted right round and through the car itself. So we try that and see how that works. And then it's trial and error. I mean, I've had some people help me with the surface modeling, because surface modeling in SolidWorks is a nightmare. So some guys have helped me sort of get a baseline. I've been running lots of sim on that as well. So running CFD and computerized fluid dynamics.
Okay.
I actually know what the official
computational fluid dynamics.
Computational.
There we go.
Who knows? Anyway, digital air and blowing a big digital hairdryer over the car and trying to see what happens. I think this is probably more trial and error than some of the mechanical elements, the suspension and things like that, because what can you do? I mean, there's only so far you can simulate these things, but the reality is it's never going to be sat straight. It's never going to be going directly into the wind, and you're never not going to have a slight crosswind and everything else. So trying to get it about right, trying to hit about 50% of weight as downforce, and trying to get that pretty evenly balanced across the car.
That was actually going to be my next question. Again, I'm not an aerodynamicist by any stretch of the imagination. We've had some basic experience with that element with our own Toyota 86 race car, and from the driver's seat, the difference is literally night and day. And I'm still learning 2 races in exactly how much harder I can drive the car than I could previously. So from a non-professional driver's perspective, it really is a bit of an eye-opener. Now, my question here is around the sort of balance, the aero balance of the car, because with the rear wing, that's relatively easy to make some pretty significant adjustments. You've got the rear tunnels or diffuser at the rear, obviously creating a lot of downforce as well. In a sort of a conventional car like what you're running here, often it can actually be more difficult to get the downforce at the front with the splitter design, and particularly getting any adjustability in the front in terms of making aero balance changes as required. So can you talk to us a little bit about the challenges there? Is there anything you've done to get adjustability in the front?
Yes, it's a bit awkward. The car's got quite big arches on it because the wheels are pretty wide to get that power down. So that means you've got winglets on either side that you can play with. So there's 3 as standard, but you can take some of those off to reduce the downforce. I imagine you can make those bigger as well. So that air that's coming over those front arches can be accelerated or decelerated as you need it to. I've played with an exit from the diffuser around the back of that front arch. So effectively, if you think about the way the diffuser works at the back of the car, but trying to do that further up the car itself and venting it out behind the front wheel, that's an experiment. I've got it as a module to fit into the floor, so I'm going to try that. I've seen a couple of cars do it. I think it's quite often regulated out of most categories, so people haven't played with it very much, but seeing as aero is pretty open in Hillclimb, I'm going to give that a go. And then you've got the ducting itself. So you've got your splitter, then you've got effectively an adjustable height piece that is your downward force. So as the air goes over the splitter and it hits the front of the car, the more air hitting the front of the car, the more downforce you're going to get on that splitter. And that piece is actually adjustable. You end up ducting off some of the radiator to the engine, which may or may not cause some issues, but you've probably got 30-40 mil of adjustability in there, and I think that should also give you a little bit of tuning, particularly at the higher speeds where you don't want the car to start pitching forwards as you get up to speed.
Yeah. I think one of the challenges definitely with high downforce is getting that aero balance to start with, but also maintaining it so that, as you said there, it doesn't do anything silly at higher speeds. Your target there, 50% of downforce, so we're talking 425 kgs. At what speed are you expecting that?
So that's at the moment at about 120 miles an hour. The car is geared to max out about 150. I think looking at, even the European courses are only, some of the longest ones are about 5 kilometers. So it's a really short race. You've got one lap, one go, and a lot of that lap will be at quite low speeds as you go around hairpins and really aggressive, steep off-camber turns. So the aero is quite a weird requirement. It's not like going around a track where you're always doing an average of 100, 120 miles an hour. This is literally going from 10, 15 miles an hour halfway through a lap back up to 150.
Okay, so we've talked about the suspension and the aero, and as you've just pointed out, the aero's probably not going to give you much of an advantage in terms of grip, traction, etc. At the lower speeds that you do tend to see a lot of in a hill climb. Which brings me to the next aspect of the electronics and what you can use there to help optimize the power delivery. So we haven't talked about the electronics package at all so far. Can you give us a quick rundown on what components you're using?
Yeah, it's so most of the system is Motec. So it's an M190 ECU, their PDM system, 32s and 16s. Then there's a couple of dashes and data loggers. So I've got the big beast the 1812, the 12-inch display that's mounted vertically. Sure. It's pretty cool. Makes it feel like a spaceship. And then a little dash logger in the steering wheel as well, because why not? Why not? And then you've got the electric power steering, which is DCE. That's a really nice piece of kit, and that's got its own little ECU as well. And a Bosch ABS system as well. So between that Motec setup and the Bosch ABS is probably your biggest advantages to try and get the power down, because obviously you've got some pretty good traction control that you can play with almost infinitely in the Motec system. So there's a lot of, I've still got to build this car, and now I'm thinking I've got to program it. That's going to take another year. So you can basically code the car to know what it's doing and handle the different power at different levels. And it's got some really nice sort of preset settings that you can run through as well. So you've kind of got every scenario covered. And then the ABS, the faster you go, the faster you need to stop, and the faster you stop, the faster you can speed up again. So that's going to be quite important, I think, particularly over a car that, as you say, at those different speeds is going to react very differently in the corners.
Yeah, absolutely. And I mean, with Hillclimb as well, it's not like a road race application where you're doing lap after lap and you're seeing the same corner, maybe 20 times in a session. With the Hillclimb, you kind of get that one crack at it. So trying to get everything optimized, and ABS is nice. I mean, I know there's some arguments it takes away from driver skill. Yes, I'm not going to argue that, but at the end of the day, it gives you a little bit more of a safety buffer there as well if you maybe misjudge your braking point just marginally. So personally, I'm all for it. I know that's not maybe everyone's take on things. Obviously, you haven't got the thing up and running yet, so you haven't been able to really dial in some of the controls that you'll have at your fingertips with that Motec ECU. But in terms of the power delivery, one of the nice things with turbochargers is obviously we have the ability to adjust the boost. So it's safe to assume you're going to be taking advantage of that with gear or speed dependent boost to reduce the power and torque at lower speeds.
Yeah, and I'm playing with something that I know you picked up on a few weeks ago, which is using the smaller throttle bodies as your dump valve in the boost as well. So not just having a spring-loaded pressure set boost, but actually being able to trigger it electronically. So that is effectively you've got the wastegate, which I've got from Turbo Smart, do these electric wastegates that are basically solenoid controlled rather than being controlled by the air pressure. So you can do all sorts of crazy overboost, underboost, random boost triggers, things like that. But then also doing that on the inlet side, on the manifold pressure side, using a little throttle body. Gives you all sorts of flexibility to vary the boost depending on what gear you're in, what speed you're in, where you are on the hill, etc. That's quite an interesting opportunity, and will take a lot of playing with. 'Cause one of the things to remember is Hillclimb. I mean, some of these race weekends, I'm looking at people that win their class, which means they've done every possible practice and race, and they've been out 6-8 times. Imagine doing a whole race weekend where you win and you've still only done 8 laps, and you've managed somehow you've got to use the data. It's bonkers. So you've got to do as much as you can. I bought a simulator to try and play with it. So I built the car basically in a couple of sim programs. I built the car and I'm playing with it and with data on some of these hill climb tracks in the sim. But it's never going to be the same. I mean, that's the real basic garage attempt at doing what Formula One do, but you're never going to quite get there. You have to go and drive these things.
Yeah, absolutely. But I think that the sim is definitely a valuable tool. Maybe a few years ago, simulators were viewed more as a toy, a game, and these days there's no denying that they are a valid training tool. I was involved with a couple of attempts at Pikes Peak, And while my own driver that I was involved with didn't use a simulator, ended up talking to Robin Shute, who won the unlimited class the year that we were there. And he said he'd spent months on the simulator prior, because again they get very limited testing.
Is so long.
Yeah. You get limited testing coming up to it, and then on game day it's literally one run, 8 to 9 minutes depending how fast you're going, and they're using the simulator there to actually memorize the track, so they know exactly what's coming up. But I digress. We're probably getting a little bit off track, but just it is important to understand that is a valid training tool, provided you've obviously got a reasonably accurate representation of the track you're racing at, the Hillclimb, and obviously it'd be nice to have an accurate representation of the vehicle as well. In terms of getting all of these electronic components talking together, you've done the wiring on this yourself, I understand, so you're a man of multi-talents. Talk us through that.
Yeah, that was I looked at what it would cost to get someone to do it, and I can now appreciate why it costs what it costs. There are hundreds of hours that have gone into those looms. So I couldn't do any of that. I know basic electronics, but I've never done any wiring. I've certainly never done any, concentric twisted looms before. So I sat down one Christmas and I went through all of your guys' videos on, how to wire a proper car. And then I sat down and I shouted at it, at the kitchen table for 2 weeks. I was like, why do these wires stay where they're supposed to be? I don't get it. I'm watching this video, and who did the video? Was it
Zach?
Ben that did the video. It was Zach that did the video, and
Zach,
he's there just laying these wires up, and everything just sits perfectly, and then I'm laying them up and they're just springing back, and then it just clicked 2 weeks in. It was like, oh no, that just works now. Set to work doing all of this concentric, fully sealed, all Deutsch Autosport connectors and Lemo connectors, and kind of outdid myself there. I think the first loom was, I reckon, 50 to 100 hours for the chassis loom. And you have to bear in mind that it probably doesn't take that for somebody who knows what they're doing. But for me, it was trying to work it out at 2 hours at a time on a weekend. It took me a long time, and now I've still got, I reckon I've got another 100 hours of wiring to go into this car. But it looks great, and it's pretty cool.
It's a time-consuming process, no matter, I think, what level you're at. And as you alluded to there, that is why if you want to pay a professional to build a professional motorsport harness, it is going to be an expensive exercise. But as you do become a little bit more familiar with the process, particularly the concentric twisting, and I 100% agree, I don't do it often enough now to be really proficient at it. And every time I go back and build a harness, and we built one for the SR20 last year, and the first sort of 3 or 4 days I'm pulling my hair out, and then it all starts to come back to you and click. And as you say, that concentric twisting in particular, it is one of those skills where you do need to understand what you're trying to achieve and the techniques involved, but then you actually have to get involved and do it to become really proficient at it.
But it gets out of hand. Joel from Bracespec showed me how to do a contra-helical twist, where you basically twist, one big trunk going in one direction, and then you twist a little trunk that becomes one of the strands going around the big. And those things are just crazy. They look like some sort of mad DNA. And now I'm just trying to put silly little flares like that into it. And the worst thing is you spend hours on this stuff and it looks incredible, and you post it on Instagram, and then the next thing you do is you cover it in heat shrink and no one ever sees it again. It just looks like a big cable.
Yeah, that is a bit of frustration. Yeah, all of that tidy work that you've done and all of that effort does get hidden under the DR25. But I would say that when you've done it properly, the DR25, you can tell when that's shrunk down over something that's been properly twisted, and it sits really nice. I don't know. I get a bit of satisfaction out of it. You can still sort of see the silhouette of the wires underneath. You know it's right. It's good.
Yeah, no, I love it. And then also, wiring is such a horrible thing to diagnose when you're on race day in the pits. So making sure that's done right, yes, you can get this stuff laid down really quick and easy, but it'll be the first thing to fail and you'll never find it until you get home and you've wasted the whole trip.
Yeah, yeah, and from my career of 15 odd years professionally tuning, wiring issues were the number one problem that I would strike when tuning customer cars on the dyno, and it is infuriating, not just from the tuner's perspective because you're wasting time, but you've got a car that is bolted to the dyno and you're trying to go through and fault find this and try and figure out why you've got some crazy sensor readings or whatever, and usually something that could have been solved relatively simply by understanding the basics and doing a better job when the wiring harness was being designed and built. Safe to say, you shouldn't have any of those issues with the complexity of your system and the quality of the work. One of the problems we see with a sealed mil-spec harness, like what you've constructed though, is it doesn't give a lot of flexibility for changes, modifications. Have you done anything in the way of future-proofing? Maybe you want to add some sensors at a later point or anything of that nature?
Yeah, you'll see that the car's full of junction boxes, not just because they look great, but because that gives it a huge amount of flexibility. So the car's broken up into about 12 official sections. So each of those sections has a loom, which gives you a much smaller piece of wiring to modify if you need to change in the future. But again, each of those sections then has a junction box. So all of your spare sensors are available on that box, lots of spare CAN termination points that you can plug into and add devices. There's quite a bit of... I think because as I've built this, I've learned things, and a lot of things. I've always been quite careful to future-proof stuff. You'll see in a lot of the parts I design, I add extra holes, and it looks like I haven't fitted something yet, but that's not what it is. They're there in case I decide actually something else needs to be mounted here, or rather than remachining the full 10 kilograms of 5-axis machine billet, there's just some holes left over that you can mount stuff to, and that's been quite important because almost every time I receive something back, I'm like, right, now I want to add this bit, and I don't want to start again. Yeah.
I think that's the sort of design elements that really come from experience and can be so easy to overlook when you're just getting started. I just wanted to touch on as well that the ability to expand on the electronics package these days has become significantly easier because we're seeing a lot of companies now come out with CAN-based sensors, and as you mentioned there, if you've got a spare connection for CAN, it's really as simple often as connecting up 12 volts ground, CAN high and CAN low, and you've got infrared tire temp sensor or brake temp sensor or laser ride height or just about anything you could imagine. So
PDM, I mean, you can expand. You can basically build another car on the end of one ASL.
Yes. Yeah, true. I guess you've probably just about got shares in TE connectivity at this point with a number of autosport connectors on the vehicle.
Yeah, I'm kind of lucky that we work with them as a business as well, so I'm not quite paying consumer prices on it, but yeah, there's certainly too many of those in there.
Nice. All right, look, Josh, I think we'll work towards wrapping this up. It's been great. We could probably go on for another hour, but I'm sure you've got other things you need to do as well. A couple of questions that I want to finish up with here. So first of all, if you could sort of look back on your career at this point and maybe give advice to a younger version of yourself, maybe someone out there who's looking at a career path similar to what you've gone down, is there any advice you would give now with the benefit of the experience you've had?
For me, I think it's very important to remember that no one ever gets in trouble for trying. And I think it's so often overlooked that actually a lot of things are possible if you give it a go. And the reason why the majority of people don't do things is they don't try. So play. No one's going to tell you off because you gave it a go. And I think people sometimes are quite scared to stick a toe in and give it a try.
Yeah, I think we are raised, and I think the school system actually has a little bit to blame, takes a bit of blame here. We're raised to sort of feel like failing is not acceptable, but that is really how we learn. So I think you're absolutely right. I mean, trying some things and maybe not all of them are going to work out, but you're going to actually learn from those failures and progress quicker than if you sit there doing nothing, obviously.
I think anything worth doing is probably 400 to 1. So 400 attempts to 1 success. And so as long as you can take those 400 slaps in the face you can go and do something quite interesting. And I think as long as people remember that and you have perspective of it, it doesn't feel like failure. It just feels like trying to get to that 400 so you can get the one at the end of it.
Yeah, absolutely. Again, so easy for everyone to overlook, and people mistakenly think that you're going to get success on your first attempt. I can't remember, it's probably been said a million times, and I'll probably get this all wrong, but I think Thomas Edison, when he invented the light bulb, he failed multiple times, and he said that he didn't fail, he found 1,000 ways not to make a light bulb, but he only needed one that actually worked, and here we are anyway. And lastly, to finish up, Josh, if people do want to learn more about this amazing car you're building and follow your journey, how can they reach out? How can they follow you?
Yeah, you can follow me on Instagram. I post all the build under motorsport_engineering. Try and post everything that's going on, all the CAD, all the design features. I'm looking for people to come and comment, come and tear it apart, tell me what's wrong, tell me your ideas, show me interesting stuff. I'm really keen to kind of get as much input as possible on this build. It's down to everybody that's been part of it, through Instagram and through everything else, that I'm thankful we've got this far.
Yeah, well, look, we'll link to that in the show notes, and I certainly appreciate you putting all of that work out there. I've loved watching the journey so far, and it looks like you're getting close towards the end of the project, so I'm certainly looking forward to actually seeing it run, and maybe some video of it competing at a Hillclimb. So we wish you all the best when it comes time to enter your first event.
I have to get you down here to come drive it.
Oh, I would absolutely love to. Let's hope we can travel again.
I think it's probably
soon.
got like a 5'6" limit on it.
I can shrink. I'm 5'10", but I can definitely shrink if need be. I'll do anything. Yeah. All right. Thanks a lot, Josh. Really appreciate your time.
Let's go. All right, man. I really appreciate it. Thanks for having me on.
All right, that concludes our interview, and before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school, and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.